Today, the entire internet is buzzing about a strange object racing toward us from the depths of space. A visitor named 3I Atlas. Most people focus on its incredible speed and mysterious trajectory, stirring up fears of alien encounters. But what is this interstellar object really hiding? And more importantly, what is its true value? 3I Atlas isn't anything extraordinary for our solar system. Over the past decade, astronomers have been spotting more and more of these mysterious interstellar wanderers. The first of them appeared in 2017, Oumuamua. It suddenly burst into the view of astronomers and just as suddenly disappeared, leaving behind a storm of unanswered questions. Everything about it was strange. Its long, cigar-like shape, the absence of a comet's tail, and an unexpected burst of acceleration, as if some invisible force was pushing it away from the sun. The internet went wild. Theories about alien spacecraft, ancient probes, even space junk from a buried civilization spread like wildfire. But the truth turned out to be far less dramatic. Oumuamua was simply a fragment of frozen nitrogen, or a similar material, ejected from a distant planetary system. When it approached the sun, its surface began to evaporate, not in the usual way of comets that release water vapor, but by emitting lighter gases such as nitrogen or carbon dioxide. This evaporation created a small reactive push, a natural jet effect, that satellites mistook for anomalous acceleration. No engines, no alien technology, no threat to humanity, just basic physics acting on an unfamiliar material. Just a few years later, Ukrainian astronomer Gennady Borisov spotted another mysterious interstellar visitor. The comet he discovered looked perfectly ordinary, except for one thing. It came from another solar system. This time there were no wild theories or doomsday headlines, because the real secret of Borisov's comet lay in its composition. It carried with it a sample of alien chemistry, something entirely different from what we find in our own cosmic neighborhood. And now, we have 3I Atlas, the fastest, the most talked about, and the most mysterious of them all. Yet many of the qualities you've probably heard about in the media or seen in videos are, frankly, exaggerated. First, the speed. Yes, compared to its predecessors, Oumuamua and Borisov's comet, 3I Atlas is like a racing bullet next to a family hatchback. Its incoming speed relative to the sun was almost 60 kilometers per second, while Oumuamua clocked in at just 25. But let's be honest, on a cosmic scale, that's nothing. In the grand traffic flow of our galaxy, such velocities are routine. Stars, planets, and clouds of gas and dust all swirl around the center of the Milky Way at roughly 200 to 220 kilometers per second. Against that backdrop, 60 kilometers per second is just a small difference in the local traffic speed. The fact that 3I Atlas is moving so fast isn't a miracle. It's statistics. In space, speed is just another characteristic, like age or temperature. It doesn't make an object special, but it does help us figure out where that object came from. The second supposedly alarming feature is its trajectory. 3I Atlas is traveling almost along the same plane in which all the planets of our solar system orbit. When astronomers calculated its path, they found that the angle between its orbit and this plane was only about 5 degrees. That's so small that some people immediately suggested it must have been intentionally aimed, as if the comet were gliding past each planet on purpose, studying them one by one. But again, reality is far less thrilling. The position of its orbit is exactly what makes this object visible to us. Our telescopes on Earth and in near-Earth orbit are aligned within the same plane, which means we mostly notice objects that pass conveniently through that line of sight. In other words, we see the comets that happen to fly toward us, while countless others slip by unnoticed. Those apparent close encounters with planets only look dramatic in projection. In reality, the distances involved are enormous. Even at its closest approach to Earth, Atlas will remain over 270 million kilometers away, nearly twice the distance between Earth and the Sun. On a cosmic scale, that's not a visit. It's more like a faint wave from afar. There's no inspection, no reconnaissance, just a traveler from the depths of the galaxy quietly crossing our patch of space, without purpose, without intent, and we, tiny observers on the third planet from the Sun, happened to catch the brief moment when two worlds' paths intersected. At the same time, 3I Atlas isn't just another ordinary interstellar object. The real secrets, the ones worth being intrigued by, lie in its chemical makeup. Early telescope observations revealed something surprising. This comet isn't evaporating water, but carbon dioxide. In its coma, the cloud of gas surrounding it, carbon dioxide molecules dominate, while water is almost absent. That's highly unusual for comets as we know them. Typically, when a comet nears the Sun, its surface heats up, the ice melts and vaporizes, and jets of water vapor burst outward, pushing dust into space and forming a long, glowing tail. But Atlas behaves differently. Its ice isn't made of water. It's carbon dioxide ice. That type of ice starts to evaporate at much lower temperatures, which means 3I Atlas wasn't born in the warm inner region of its home system, but out on the distant frozen edge, where its parent star's light was already weak and cold. In other words, we're looking at a fragment of another planetary system, preserved in the icy darkness where it formed long ago. Its composition makes 3I Atlas something like an archaeological artifact, a piece of an ancient planetary disk that took shape billions of years ago around another star and was later cast out to wander through eternity. Scientists were stunned. The ratio of carbon dioxide to water was nearly 8 times higher than in any known comet of our solar system. That's not just a statistical outlier. It's a completely different kind of object. Some researchers suggested that its surface might be covered by a dense crust, blocking the release of water vapor. As the Sun heats it, the water stays trapped inside, while only the more volatile gases, like carbon dioxide, escape. Others believe 3I Atlas may have formed in a carbon-rich protoplanetary disk, a sort of alien twin of our Kuiper belt, where gas and dust came together to form icy bodies. If that's true, Atlas carries within it the chemical fingerprint of another star system, and that's its greatest mystery. Oumuamua puzzled us with its shape, Borisov with its familiar appearance, but Atlas astonishes us with its composition. It's as if the comet itself were saying, "I'm not from your world, and even my laws of freezing are different." That's why telescopes all over the world are now pointed at it. Space observatories, including the James Webb, are trying to capture the faint light reflected from its coma to determine exactly which gases and dust particles it's releasing into space. Because this isn't just a matter of chemical numbers, it's a window into another solar system. It's a chance to see how planets were born there, what elements filled that world, and how different it was from our own. So, there are no monsters here, no invasions, no sensational discoveries, but something far more fascinating. Every interstellar object like this is a time capsule from another planetary system. It carries the raw material from which alien worlds, perhaps even other Earths, once formed.